Today we're going to discuss what makes something an acid or a base. By the end of this lesson, you should be able to identify substances as acids or bases using the Bronsted-Lowry definition. Earlier, we've defined an acid as any substance that produces H+ ions when dissolved in water, and bases as anything that produce OH- ions when dissolved in water. However, there are substances that behave as bases that don't have the OH- ion in them. So another definition of acids and bases has been developed that allows those substances to also be classified as bases. In this definition, the acid is almost the exact same definition as before. Before it was acids produce H+ ions. Here it's acids donate the H+ ions, meaning they're giving them up, so they're producing them in the solution. However, bases, instead of producing OH- ions, bases are going to accept the H+ ions from an acid. In order to determine whether something is an acid or a base in this definition, you have to look at an actual chemical reaction. So here I have just a generic reaction between an acid and a base. X and Y are variables here, not actual specific elements. And you can see that the HX and the X- differ from each other by just an H. And the Y and the HY+ differ from each other by just an H. So we have something that is giving up an H+ ion to another substance and a different substance that's accepting it. So the first thing to do when determining whether something is an acid or a base in the Bronsted-Lowry definition is to identify the conjugate pairs, which are the two things that differ only by the H+ ion. So our first conjugate pair is HX, which is becoming X-. In order for HX to become X-, it has to lose or donate the H+ ion. And something that donates an H+ ion, by definition, is an acid. So here HX is acting as an acid. Y is becoming Y-, so that is our other conjugate pair. And for Y to become HY+, it has to accept the H+ ion, and things that accept H+ ions are bases. So here Y is acting as our base. So notice we'll have one acid and one base on the reactant side. Now this is a reversible reaction, so we can identify the acid and the base for the reverse reaction as well. Well, X is turning back into HX in the reverse reaction. In order for X- to become HX, the X- must accept the H+ ion. And things that accept H+ ions are bases. So X- is the base for the reverse reaction. Notice for my conjugate pair, one is an acid, one is a base. In order for HY+ to turn back into Y, it must donate the H+ ion, and H+ ion donors are acids. So HY+ in the reverse reaction is acting as the acid. So on both sides, I have an acid and a base on the reactant side and an acid and a base on the product side. And one member of each conjugate pair is an acid and the other one is a base. So here is a specific example of an acid-base reaction. We have NH3, which is ammonia, plus water, forming NH4+, the ammonium ion, plus OH-. So take a minute and identify the pairs, the things that are differing from each other by just an H+, and identify which is an acid and which is a base. NH3 differs by just an H+ ion from NH4. So NH3 is becoming the NH4+ ion. In order to do that, the NH3 must accept an H plus ion. It has to get another one. H plus ion acceptors are bases, so NH3 is acting as my base. In the reverse reaction, NH4 has to lose or donate an H plus ion in order to go back to be NH3. So NH4 plus is acting as my acid. The other conjugate pair is H2O and OH minus. So H2O is becoming OH minus. In order for H2O to turn into OH minus, H2O must donate an H plus ion, which means H2O is acting as my acid. In the reverse reaction, OH minus is becoming H2O. In order to do that, it has to accept the H plus ion, which means OH minus is acting as my base. So again, we have an acid and a base on the reactant side, an acid and a base on the product side, and one of each conjugate pair is an acid and the other one is a base. Now, one thing that you might notice is here we have water listed as an acid. So what I want you to think about is water really an acid? So what is it that makes us identify it as an acid here, and is that always going to be the case?